Welcome back, okay? Today I'm going to teach you about terminating and repeating decimals. This is Chapter 5, Lesson 4, okay? This Chapter 5 is going to be finishing up our first textbook, okay? The lesson essential question that we've been dealing with for this chapter that you have heard before is called how are integers and absolute value used in real-world situations. Okay, we've talked about this before. You should be able to answer that essential question right now. Okay, we've talked about how integers are used. What is an integer? Do you remember what an integer is? Integer is any whole number that is positive or negative. Okay, it's a whole number that is positive or negative. It doesn't have a fraction, doesn't have a decimal. Okay, and we talked about how you can talk about in football how they get penalized. They go back, 5 yards, or if they make a positive reception of 4 yards, those are all integers. And then we talk about absolute values. All right, when they talk about absolute values, what they're really saying is that instead of using a negative number, they use a positive number, okay, but it can be moved either forward or backwards depending on the situation, right? If they say they lost 4 yards or they got penalized 4 yards, they don't say negative 4 yards, right? They say penalized 4 yards. That is an absolute value. 4 is the absolute value of a negative 4. They don't say they go negative 4 yards. No, they say they lost 4 yards, which we know means an integer of negative 4. But they use the absolute value of it and just say they lost 4 yards. Okay, and that's just one of many you should be able to come up with on your own. All right. The lesson essential question is how are repeating decimals used in the real world situation? I will answer that question on the next slide, okay? All right, any number that can be written as a fraction is called a rational number. Every rational number can be written as either a terminating decimal or a repeating decimal, okay? We have been working with terminating decimals. In other words, the numbers stop, okay? For the most part, we have been using that. Now, we have run into repeating decimals, okay? But we haven't been really working on them. So we're going to work on them with this lesson, okay? Right here it says in your book, you should have your book open, all right, to whatever chapter this is. Let me go see if I can find a page number for you. 379, right? You should be able to page 379, all right? It's, again, chapter 5, lesson 4, all right? It asks us to draw lines from each word to its matching statement, all right? It says terminating decimals, okay? Is a terminating decimal a decimal form of a rational number that's like 0.3333333? No, because it never stops. It's not terminated. It doesn't stop. Okay, so that's wrong, all right? A terminating decimal is the decimal form of a rational number which has a repeating digit of 0, okay? Now that's it's a little I don't really like how it could be a slight misleading, okay? But what they mean is something like this. Okay, sorry about that. All right. So a terminating decimal, all right, is the decimal form, which I'm going to tell you right now. It's this one. All right. The decimal form of a rational number which has a repeating digit of 0. That means this. Right? You can put as many zeros behind this as you want. That's what they mean by that. I don't like the way they define that. What I would have said was you can actually solve the division problem or something like that, where it doesn't have a repeating number, all right? But I guess that's a better way of saying it. I don't know. I don't like the way they said that, all right? And there's only two things to be talking about here. So a repeating decimal is obviously the other one. Decimal form of a rational number, .333333333. Okay? Those are not the only type of numbers that do that, okay? All right. Real world link. You should be filling this out as you go along, okay? For those of you who are skipping around and not watching my video, I do not appreciate it. You should be filling this out. I will be grading your math folders, okay? And if they're not filled out correctly, you're gonna get a bad grade on that, all right? All right. Real world link. Party favors. Jude is buying fruit snacks for party favors. He asked the cashier for a half a pound of fruit snacks. Express 1/2 as a fraction. You should be able to do that, right? Half looks like this. Okay? Right. Then it says, number 2 says, write the decimal form that represents a half pound. Okay? Remember, you do division. It's the top divided by the bottom. right? And we know that probably instinctively that 0.5 is a half, or you should by now, okay? But I just wanted to show it so you just saw. Suppose Jude wanted to buy 1/3 of a pound. What decimal would that scale show? Okay, now we have a third, right? Take the top and you divide it by the bottom, right? Okay, now you should be able to almost tell immediately what this is going to do. Okay? All right, see what it's going to do? It's just going to keep repeating. All right, and the way that we represent that is with the bar. They call this the bar notation. Okay, so suppose Jude wanted to buy 1/3 pound. 1/3 of a pound. What decimal would the scale show? Here we go. Now, depending on the scale, which scales probably only go out, if it's an electric scale, it'll probably only go out to like 4 digits or so. Okay, but if it's a an actual scale in which it has a little hand dial and it moves and bobs, you wouldn't know, right? You wouldn't be able to tell that. You just have to look at it and be like, oh, okay, that's about 1/3 of a pound. Okay, and it'd be right around wherever you would think 1/3 of a pound would look like. But that's what it would look like on an electric scale, you know, or as they call it, a digital scale. Okay. Also, to answer the essential question, the lesson essential question, usually what they show a repeating decimal in is like baseball averages, like batting averages. Like if somebody has .333 or .111, like that type of idea, or .222, that's a repeating decimal. Shooting averages, but really they call it shooting percentage, so maybe you wouldn't see it there. Averages and stuff like that. Like normally you really wouldn't see it. Maybe in a weight of something you might see it repeated, but I don't really think that it would show very often. Okay, it's not really used that often, but it is used. It's not like it's not used. Okay, rational numbers. Let's talk about rational numbers. Okay, rational numbers can be written as fractions. Any number that can be written as a fraction is considered a rational number. Okay, algebraically, it is a over b, where a and b are integers and b is not equal to 0, because you cannot divide anything by 0. All right, it errors out for you. So as you look here, they got whole numbers in the yellow here, but those are considered rational numbers, right? Because you can write a whole number like that as a fraction, right? Okay. Then it says integers. That's just a negative number. Look, ta-da! You know, you still have a fraction as a whole number. All right. And then it says rational numbers are any number that can be written as a fraction. So 1/3. You know, any number. You just pick it. Okay, as long as it doesn't have a 0 in the denominator or in the numerator, then you're fine. Not in the numerator. You can have 0 in the numerator. All right, because this is fine. Right, that's just equal to 0, right? Okay. Okay. Fractions, terminating, and repeating decimals, percents, and integers are all rational numbers. Every rational number can be expressed as a decimal by dividing the numerator by the denominator. Okay, now what they're saying is that up here in this rational number, 25% is a rational number, because that's what? 25 over 100, right? And it also says any terminating decimal, repeating decimal, any fraction, percent, or integer. Okay, all these numbers are rational numbers. Okay, it's pretty much every number except a few. There are a couple irrational numbers. Let's not talk about pi is a irrational number. Okay? All right. Every rational number can be expressed as a decimal by dividing the numerator by the denominator. And we know that, right? Here are some examples here on this little chart right here. Right here. All right, 3/10 is 0.3. See how you can see the repeating decimal is going to be 0? But we don't do that, right? We don't write all those zeros. That's ridiculous. We just terminate it right here. We just terminate it right here. All right? This one does not terminate. So we would have to do this. This is called the bar notation. Also, the way that they have it written here with the 3 dots after it, that's also very acceptable. Okay? That means it's repeating the same number over and over and over. Okay? All right? To indicate the number pattern that repeats indefinitely, use the bar notation. Bar notation is a bar placed over the digit that repeat, right? I showed you up here by just putting a bar over this. That's fine. Then you wouldn't have these. You wouldn't have these all of a sudden. You just not have this, right? You just do that, all right? All right, here's some examples, 0.545454, right? It's just a repeating, right? And then you got 0.5833333333. Now, I know that we have talked about not saying 0.583333, but when you've got a repeating decimal like that, that's the best way to say it, okay? You could also say it like 54 hundredths repeated, but I would not say that. I would just say 54.54 with a bar over top of it, all right? And over here, you'd say 0.583 with a bar over top of the 3. Be very specific over what number has the bar when you're speaking about it, okay? All right, here's an example, all right? They're not doing anything you should not be able to do here. I'm not even going to work it out for you because, look, they've worked it out for you. The main thing is you need to learn to write it either one of these two ways. It doesn't matter how you write it. Pick a way, stick with it. You can change, interchange, I don't mind, okay? But you really shouldn't. Pick a way and stick with it, okay? Now they want us to write each fraction as a decimal. Use bar notation if necessary. Pause this video. Do all three of these. You should be able to do all three of these. Remember, it's the top divided by the bottom, which I should not have to say. All right? Pause the video. I'll wait for you. Okay, you paused? Good. Here I'm going. Wow, you're paused. That's kind of funny. All right. 6 goes into, right? 6 can't go into 1, so we put a 0. 6 can't go into 10 one time. 6, and then you got 4 left over. Bring down the 0, annex the 0, bring it down. 6 goes into 4, 40. 6 times for 36, and here we go. Here we go. As soon as it repeats once, stop. Okay? Don't keep working it out. As soon as you see it repeat, stop instantly. Okay? If you want to do one more, I'm okay with one more. Okay? To make sure that it's going to do the same thing. I'm okay with that. But as soon as it does, and that's how I write it. Okay? I don't like writing the 3 dots. I don't have a problem with it. I'm just trying to make life easy for myself. All right, now looking at all three of these numerators, or denominators, not numerators, denominators, okay, looking at all three of these denominators, I know that they're going to repeat. Okay, 6, 9, and 11 all repeat. 7 repeats, 3 repeats, okay, there are a bunch of others that repeat also. All right, and I will show it to you here, right? So you should, again, pause the video, do B and C. So you got 9 divided into 8, right? 9 can't go into 8, so you bring up your decimal, annex a 0. 9 goes into 80, what? 9 times 4, 72, so that wouldn't be 9, that would be 8. Sorry. That would be 8, not 9. 8, right? And then you subtract it, all of a sudden, oh my gosh, you got an 8 again. Bring down the 0, it's going to be, blah, blah, right? I don't care if you know, that's how that looks, okay? 0.8 with a bar over top of it, or 0.88 with a bar over top of the last 8, okay? Doing C, 11 divided into 2, okay? 11 can't go into 2, so you give it a 0, annex a 0, right? 11 can go into to 20 one time for 11, all right? And it's going to bring you 9. You got 9 left over, bring down the 9, and then all of a sudden you're going to have an 8 for 88, and oh my gosh, it's going to repeat. Here comes the 2 again, right? Now 1, 11, 9, whoops. Yeah, that's right. Yeah, 8, right? Right? You see that? Very simple, very straightforward. This should not cause you a lot of problems, okay? Which is a great relief from the last one that we did, right? The convert measurement units, okay? Now it says write a negative fraction as a decimal. There is no difference in solving for positive or negative fractions. You just make sure you keep the negative sign if it's a negative fraction. All right? Just write the negative sign in front of the decimal. Okay? When writing negative fractions as a decimal, the process is the same. Divided with positive fractions, write the negative sign in front of the decimal. Look, no big deal. Okay? It talks about here. It says this right here. Okay? This is not too bad of an idea. When dividing, it is sometimes helpful to divide until the repeated pattern is shown at least 3 times. Okay? I said, once you see it repeating, okay, maybe you should go 3 times. I'm okay with that. All right? Maybe 2's a little bit too early, but I don't know. It just depends. Depends on how you feel about it. You know, I know that you're lazy as a student and you're just trying to get it done, but try to do 3 times, okay? But at least 2. At least 2, okay? At least twice. Okay? I want to see it at least repeated twice before you put it in bar notation or in ... form, right? All right. All right? Right? Each fraction is a decimal. Use bar notation if necessary. Again, this is the same thing that you do as with positive numbers, except that they're just negative. You just put a negative sign in front of it when you're done. When you're done, okay? You do it as you divide as normal, and then when you get your answer, just put a negative sign in front of it. Okay? And look, 1/4, we know what 1/4 is, all right? So we're going to do it real quick, all right? You should pause the video, right, and solve these on your own, because me doing it for you is useless. You need to do this, okay? But I will show you. It's okay if you don't want to do it on your own. Just follow along, right? We know this. Right? We know this one. This one is not a repeating decimal. But what they wanted to tell you is that this is negative 0.25, okay? Now let me give myself some room over here. Now this one is going to be a repeating decimal because it's got a denominator of 6. Okay? 6 goes into 5, right? 6 can't go into 5, but it can go into 50. What, 8 times for 48? And then you get this 2, right? And then you, what, 3 times for 18? And then there it is. Okay? And there it is. All right, I'll make sure I do it twice. All right, just to make sure we understand where it repeats at. And then you can see that the 2's are repeating. All right? Then this is negative 0.83 with a bar over top of it. Okay? You don't have to write all the 3's here. We can tell when the repeating is happening. Okay? All right. Let me give myself some room for this next one. All right. Whoops. Let me erase that. See if I can grab this. Pull this down a little bit. Yeah, I know. Okay. Bring this one over here. Now, when I do this, the way that I divide mixed numbers like this, or the way that I turn it into a decimal form, what I do is I put the whole number off to the side. Okay? I put the whole number off to the side. Okay? I don't turn it into a mixed number and start dividing. I already know the 2's going to be there. Okay? I just need to know what 1/6 is going to look like in decimal form. Okay, so my answer is going to have a 2 as the whole number. See how none of these had the D and E had no whole numbers in front? I knew that because there wasn't a whole number in it, and it wasn't a improper fraction, right? This is a mixed number, so I know that 2 is going to be in the answer. Okay, so I just pretty much ignore the 2. Okay, I put it off to the side, however you want to do it. So now I'm going to divide 6 into 1, right? And we know how this is going to work. It's going to go on 1 time for, it's going to give us 4, right? Here, let me get this out of the way because I don't want to write all over this. Extend page, bring this down, scoot this up, okay? All right. Bring down the 0, all right, and here we go, 36. 6 for 36. I don't know why I wrote a 3. I think I was just thinking 36, so 6, right? I got minus 36, and here's the repeat, right? And we do it twice at least just to show it, just to make sure that it's going to repeat. Look, that'll be 3 times if we did it again. So this is going to be, now remember, you got to put this 2 back in. So it's negative 2.16 with a bar over top of it. Okay? That's how I do it. I don't turn it into an improper fraction. If you feel better about turning it into an improper fraction so you don't forget the whole number, I'm fine with that. All right, let's go over here. It says here that 9 students surveyed, 4 said they preferred exercising in the morning rather than the evening. Sorry about that. I wish they gave me better warning about that. Express this fraction as a decimal. Use bar notation if necessary. It says of 9 students surveyed, 4 said. Okay? So 4 out of 9. If you can't figure that out by now, you have much bigger problems. Okay? Now, I don't know why you wouldn't be able to figure that out. But on the test, you guys couldn't figure out 23 out of 25. So if you can't find 9, of 9 students surveyed, 4 said, okay, this is what 4/9 looks like. 4 out of 9 said, Okay? You should be able to reword that in the way that you understand it. Okay? And the way that this word looks as a decimal is we got to do the division. Right? Top divided by the bottom. Right? 9 can't go into 4, but 9 can go into 40. What? 3 times for 30? Is it 3 times? 1, 2, 4 times for 36. Sorry. I didn't mean to do that. 4 times for 36. And uh-oh. Here we go. Already repeating. Right? I'll do another one. There we go. You know. So there. Like, we can see that it's going to repeat again. So this is equal to... Okay? I'll write it up here. We'll even write the 0. Okay? So that should not be too hard for you. Okay? All right? When finished watching the lesson, either put your name stick in the help bucket and start doing your notes, or if you think you can move on, put your name in the guided practice bucket and do the guided practice. Page 382 all. Okay? Once done with the guided practice, see me to check it over. All right? Then, once took, you can do the, I don't think I meant to put took there, I meant to say once done, or once I tell you, you can do the extra practice page 385, 386. Here, I'll go ahead and change that right now. Hold on. All right. Once I tell you you can, do the extra practice, page 385, 386. All right? Thank you. Have a great